So, have you ever wondered how an algorithm knows exactly what you want to watch next, or how a chatbot can seemingly read your mind? Welcome to this explainer, where we're going to break down exactly how artificial intelligence systems digest data to find patterns and ultimately shape our modern reality. We hear a ton of buzzwords thrown around every single day, but today we're stripping away the hype and looking strictly at the mechanics behind the curtain.
Okay, let's jump right into our roadmap for today. We're going to cover the AI family tree, how patterns emerge, the deep learning shift, generating new content, the synthetic media landscape, and finally, keeping humans in charge.
Starting off with Section 1, the AI family tree. Now, to understand how machine learning finds its patterns, we've got to set the stage. When we say artificial intelligence, we're broadly talking about systems designed to handle tasks that usually require human capabilities. Think perception, reasoning, language, making decisions, or taking action. AI isn't just one piece of magic, right? It's a massive field of different methods, and how they actually achieve that intelligence varies wildly.
And this brings us to a real game changer in the industry. For a long time, we relied on rule-based AI. That's where humans literally write out all the explicit rules in code, which is great if the rules are perfectly stable and never change. But on the flip side, we have learning-based AI. Instead of painstakingly coding every single strict rule, modern learning-based AI operates by digesting massive amounts of examples to discover the rules and patterns totally on its own. It literally gets better the more data you feed it.
So how exactly does it do that? Let's get into Section 2, how patterns emerge. Let's break down the core engine here. Think of this iterative training loop kind of like a student cramming for a test. First, in Step 1, we input examples, past data. Then comes Step 2, the training phase, where the model adjusts its internal connections to find useful patterns. Step 3, it stores those patterns into the actual model. Step 4, it uses that model to make a prediction, like giving something a label or making a recommendation. And finally, Step 5, it takes feedback to tweak its settings and improve. It literally learns from its mistakes. But here's the catch. How do we know it's actually finding real underlying patterns and not just memorizing the answer key? Well, we deliberately split our data. We use 70% of the data just to teach it, 15% to validate and fine-tune our choices, and we lock away the last 15% entirely for testing. That testing chunk is absolutely crucial. It's how we fairly check if the model can handle brand new examples it has never laid eyes on before. Once it's trained, it applies those patterns to all sorts of tasks. Need to know which category? That's supervised learning. For classification, like flagging your emails as spam or not spam. Asking how much? That's regression, used for predicting things like house prices. Then there's clustering, which groups similar items, like customer segments, without explicit labels. And of course, recommendation, which uses patterns to guess what video you're going to want to click on next. The magic word for all of this is generalization. A truly reliable model learns patterns that transfer smoothly to new cases. If it doesn't, it overfits. Think of overfitting like a race car driver who just memorizes every single bump and crack on their home practice track. They might drive it perfectly, but the second you put them on a new road, they crash. The moment the real world changes, an overfitted model will fail completely.
All right, let's move to Section 3, the deep learning shift.
Deep learning takes this pattern recognition and layers it, using neural networks to find incredibly complex patterns in images and text. So why did it suddenly explode in popularity? It was honestly the perfect storm. We finally had massive digital datasets, like imagine going from reading a few books to instantly digesting the entire internet. Combine that sheer scale of data with the raw power of specialized GPUs, massively improved architectures like transformers, shared benchmark tasks, and cloud computing. Deep learning finally had the fuel it needed to take over.
Which leads us directly into Section 4, generating new content. To really grasp the current AI landscape, you kind of have to flip the script. Traditional discriminative systems just ask, what category is this? And spit out a label, like flagging a phishing email. But generative systems ask, what new content fits this pattern? They use everything they've learned to construct original text, images, or audio from scratch. We've moved from a system that categorizes the world to a system that actually creates it. Let's take diffusion models for image generation, for example. No complex math required to understand this, I promise. Step 1 starts with pure noise, just random static dots. Then, step by step, it denoises the image. Structure starts to appear in Step 3. Shapes form, until Step 4 reveals a pristine, final image that perfectly matches the pattern you asked for in your prompt. It's basically like taking a completely blurry, static-filled picture and polishing it until the exact thing you wanted magically appears.
Okay, zooming out to the big picture now in Section 5, the synthetic media landscape.
70%. That is a staggering number. Adoption is moving at breakneck speed, with 70% of organizations already using generative AI in at least one function. Synthetic text, images, and audio aren't just confined to research labs anymore, they are literally everywhere you look.
And because it's everywhere, we really have to know what we're looking at. Media falls on a spectrum now. You've got authentic media with minimal editing, AI-assisted media where tools just enhance or transform things, fully synthetic content generated entirely by a prompt, and deceptive media, which is presented falsely or without consent. Not all synthetic media is bad, but the ethical line between a helpful AI-generated graphic and a deceptive deepfake meant for fraud totally depends on intent, context, and consent.
Which brings us squarely to our final stop, Section 6, Keeping Humans in Charge. We have to remember that a highly realistic output from an AI is absolutely not the same thing as a truthful output. That's why keeping a human in the loop is essential. It looks like this. Step 1, define your task and understand the risks. Step 2, use the AI as a support tool to draft or suggest based on patterns. But step 3 is the non-negotiable part, human review. A real person has to verify the facts, the fairness, and the privacy implications. Finally, in step 4, a responsible human approves the decision. AI is a fantastic co-pilot to suggest things, but we always have to fly the plane. So as you're navigating this fast-changing landscape, keep this verification checklist handy before you share anything. Identify the exact claim. Trace it back to the earliest reliable source. Check the date, location, and context. Compare it with reputable sources. Look for provenance or metadata. And whatever you do, please avoid relying only on AI detectors. They are notoriously imperfect and super easy to bypass right now. Treat this as your quick reference toolkit for reality.
These AI systems have completely mastered the art of recognizing and generating the patterns of our human reality. But as they scale across the globe, it leaves us with one pretty critical question to ponder. As machine learning perfectly mimics the world around us, how will you ensure that human accountability remains at the center of the truth? Thanks so much for joining me for this explainer, and definitely keep questioning the patterns you see out there.